Good afternoon, Wes St. Paul. This is Mr. B back here again today. We are done with circles. Yes, I know that's kind of crazy, but because we've been doing this since we started online teaching, but we're now going to be moving into another unit for the rest of May, and that'll take us into June. And this unit is called integers. Now, we're going to be working sort of step by step, but essentially we're only really working on three things for this unit. The first is going to be just representing integers. So what are integers? How do we show them? How do we sort of work with them? And then we're going to be adding and subtracting integers for this unit. When you get into grade 8, you'll be multiplying and dividing integers. And if you're in grade 6 right now, when you go into 7 next year, we'll be adding and subtracting them using order of operations. So for now, we're just going to look at sort of what are integers. They are introduced in grade 6, so the 7s might have seen, had some familiarity with integers last year. Integers can be frustrating for some students because, first of all, not a lot of students have familiarity working with what integers are, which they represent. Integers means just numbers. But when we talk about integers in sort of our math, we're referring to negative numbers. So we're going to be working with numbers that have a negative value, so a value that's less than 0. We've worked with values of less than 1 a lot this year. Fractions and decimals all are less than 1. So we're now going to be working with numbers that have a value that's less than 0. And these are negative values. And they can be frustrating because part of the curriculum is to really demonstrate and illustrate how these operations work. And when I was in school, and the older curriculum didn't really care so much about that. They just wanted you to do it. So they taught a lot of things to do with rules and follow this rule to get this result. So we still will do some of that, but we also need to sort of represent how these operations actually work. So for today, we're just going to be getting into some basic stuff here. Now, I've taken this PowerPoint from the University of Texas at Dallas. It's a great PowerPoint, really good introduction. I've modified it a bit to fit what I do, but it's a great sort of demonstration just for how integers work. And I apologize, my camera seems to be a little off today. There we go. So first thing you need to know, and if you were in class, I would say to copy these notes down. So you're welcome to do that, so you don't need to go back to this PowerPoint every time. But since it is this video every time. But since it's online, you can definitely go and watch it whenever you want. So integers are positive and negative numbers. So when I say the word integers, I'm just referring to a number. Again, when we're talking about integers in the math that we do, we usually don't say integers unless we're talking about negative numbers. For example, if I asked you to multiply 2 times 4, I wouldn't say multiply the integer 2 by the integer 4. I would just say multiply 2 times 4. So we usually, even though it does necessarily mean both positive and negative numbers, we tend to refer to it when we look at negative numbers. So you can see if we sort of were lining these up, we would have 0 in the middle as sort of being a neutral value of not having a positive or a negative value. And then we have the positive numbers on the right and the negative numbers on the left. Of course, the negative numbers getting smaller, the positive numbers getting larger. Now, each negative number is paired with a positive number in the same distance from 0 on a number line. So if we were working with number lines, which we might do a little bit of this unit depending on how much time we have, whatever negative number or positive number has an exact opposite of that at the opposite end of the number line. So if we had 0, we could have -1 and +1 on both sides, -2 and +2 on both sides, and so on and so forth. Now, we can represent integers, and this is really important, guys, because a lot of the worksheets you're going to be getting and the work we're going to be doing is going to ask you to use counters or chips to represent integers. So one chip for one number. And they ask you to use red and yellow counters, okay? So red tiles will be represented as negative integers. Now, you guys most likely don't have bank accounts yet, or maybe you do, but at some point in your life, you're going to be getting a bank account. And if you're ever in the negative, which means if you ever owe money, your bank account will show up as a red statement. So that means you owe the bank some money. You're in the negative. And normally black means positive, but for our unit here, we're going to be using yellow. So make sure you have a red and a yellow pencil crayon on hand because you're going to be using them quite a bit. If you don't have pencil crayon, you're welcome to use a crayon or pen or something you can use. So negative integers being represented with yellow and with red, and positive integers being used as yellow. Now, the diagram below shows two different ways to represent the number 3. So we can show the number 3 using integer tiles or chips in many different ways. So for example, here's the number 3, negative 3. We have 3 negative chips. Therefore, this is negative 3. Now, if we were in class, I would say, okay, what is another way we could show negative 3? Because there are other ways that we can show the number negative 3 without just putting down 3 negative chips. Now, this is obviously the easiest way to do it, but I could also do it like this. Now, what's happening here is we have 5 negative chips and 2 positive chips. The 2 positive chips and the 2 negative chips cancel each other out. These are what we call zero pairs, okay? They cancel each other out. So because they cancel each other out, what's left is 3 negative chips, or negative 3. And you could extend that as many ways as you want. We could add another yellow and another red. It would still be negative 3. So when we have positive and negative numbers together, they act as a cancel out. They act as what we call a zero pair. They become the number 0, which doesn't have any value of positive or negative. Now, I would ask you, can we do it in 2 more ways? And yeah, sure, you could add another red and another yellow, or add 2 more reds and 2 more yellows. It doesn't matter. If the yellows and the reds cancel out, whatever's left is going to be what you have. And in this case, it's negative 3. I apologize. My camera seems to be not staying today. I'm not exactly sure why it's doing that. I'm going to try to hold it there. Now, let's look at some different integer groups and see if you can guess what they are. So look at this one here. We have 1 positive chip and 3 negative chips. So what number do you think is represented there? Now you could pause, but if you were going ahead and saying that the number is negative 2, you are correct. And over here, we have 2 negative chips and 3 positive chips. Now these 2 would cancel each other out, and we would have 1 positive left over. So we'd have negative 2 and positive 1 on that one. And our last one here, we have 3 negative chips and 5 positive chips. Now 3 of these would cancel each other out, which means we would be left over with 2 positives. So we have negative 2, positive 1, and positive 2, exactly what we thought it was going to be. So just keeping this in mind, guys, when we're representing integers and we're using positive and negative chips, be careful that when you have 1 positive and 1 negative, they cancel out. They create what's known as a zero pair. I know I'm focusing on that word a lot because it is going to come up a lot as we work on integers together. Now, if there are the same number of red tiles as yellow tiles, what number is represented? So if there was, for example, the same number of tiles, like this, we had 3 negative tiles and 3 positive tiles. So what number do you think would be represented? Now, of course, you could pause and think about it for a second, or if you already know, the answer is 0. So if we have the same number of positive and negative tiles, the number you have equals 0. Now, that's representing integers in a nutshell, and that is really a review. If you were in grade 7, that should definitely be a review. If you're in grade 6, it may be a bit new for you, but essentially we're just working with the idea of a zero pair. If we have a negative number and a positive number, they cancel each other out. They create a zero pair or zero number, and whatever's left over just becomes that. Now we can use these integer chips to help add integers. So we can do what's called modeling with integers. And you're going to see a lot of these on the different sheets we work on. For example, let's represent negative 2 with the fewest numbers possible of tiles. So if I asked you to show me negative 2 using the smallest amount of tiles, you would probably grab me 2 negative chips and say, well, there's negative 2. And you'd be right. That's exactly what you would do. Now you could add another negative and then add a yellow positive. That would still be negative 2, but the easiest way to show it is just simply having 2 negative chips. Now, again, number 5, let's represent positive 5 with the fewest number of chips. You'd probably do this, and you'd be right. But again, I could add another yellow and a red, and that would still be positive 5, but this is the easiest way. Now, we can model addition statements as well. So what number is represented by combining 2 groups of tiles? So let's say we have this here, okay? We have 2 negative chips, or 2 red chips, and we have 5 positive chips or 5 yellow chips. And we want to write what's called an addition statement. You're going to be seeing this on the first types of worksheet. It'll give you a model like this and it'll say what addition statement is being represented. Sometimes it doesn't even ask for an answer. It just wants you to write down the addition statement. I would start with the red. And I'd look at this and I'd say, okay, the answer is positive 3, because we know that the two sets of negative chips cancel out. But if I was going to write this, I would write it as 2 negative chips, or negative 2, plus 5 positive chips, or positive 5, equals 3 positive chips, or positive 3. So writing an addition statement is just looking at the model and writing out what addition statement is being represented. Let's try this one. If I wanted to show negative 2 plus negative 3 equals what, model that out for us. So the first thing we would do here is we would draw our 2 negative chips. Now we would add in 3 more negative chips. And now the question becomes, what's the answer here? Well, pretty straightforward. You have 2 negatives. We've added 3 more negatives to the equation. So in total, we're going to have 5 negatives, or negative 5. And as an actual statement, it would be like this. Negative 2 plus negative 3 equals negative 5. Let's try another one. Here we have negative 6 plus positive 2. So again, I would start off with my 6 negative chips, and sometimes it'll give you the digits like negative 6, and sometimes it'll show you the model, or the 6 negative chips. So here's negative 6, and I'm going to add 2 yellow tiles. Now those yellow tiles create 0 pairs, so what would be left over would be negative 4, because these 2 chips, would cancel out 2 of these, and what would be left would be 1, 2, 3, 4. Whoops, I think I made it too big there. What about this one? Negative 3 plus positive 4. So I'd start with my 3 negative chips. I would add, because we're dealing with addition. And that's important. The first lesson we're doing is adding integers. We're not going to subtract yet. Subtracting is actually a lot more difficult. Not so much that it's difficult, it's a little harder to model it. But we're starting with addition, so make sure you're reading the symbols to make sure you're being asked to add or subtract. The first couple ones will just be adding, but eventually it's going to be subtracting too. And we're going to add 4 positive chips. Now 3 of these positive chips are going to create 0 pairs, which means what's going to be left is 1 positive chip. Now, we're not going to get into subtracting integers today because they're quite a bit different. There are going to be a couple of sheets for you to work on with integers, and most of them are relatively straightforward. They will give you a model with integer chips and say, what is the addition statement? Or they will write the numbers out and say, model this addition statement. Either way, you're simply drawing in negative and positive chips, creating 0 pairs if there is, and making sure you're recording what's left over. And that's generally adding integers. After a little bit of practice, most of you won't even need models anymore. You'll be able to do these quickly in your head, and that's great. Adding integers is not super challenging. Subtracting can be a bit more, but it's something we'll work through together in our next lessons. So there will be some work on this over the next couple of days. Make sure you follow along with the adding of integers, and then we'll get into subtracting later towards the end of the week or next week. Talk to you guys soon. Bye now.